Say you're out flying kites with a friend, and right at this moment, you're 40 meters away from your friend, and you know that the length of the kite's string is 30 meters, and you measure the angle between the kite and the ground where you're standing, and you see that it's a 40-degree angle. And what you're curious about is whether you can use your powers of trigonometry to figure out the angle between the string and the ground. And I encourage you to pause the video now and figure out if you can do that using just the information that you have. So whenever I see a non-right triangle where I'm trying to figure out some lengths of sides or some lengths of angles, I immediately think, maybe the law of cosine might be useful, or the law of sines might be useful. And so let's think about which one could be useful in this case. Law of cosines, and I'll just rewrite them here. The law of cosines is c squared is equal to a squared plus b squared minus 2ab cosine of theta. And so what it's doing is it's relating three sides of a triangle, so a, b, c, to an angle. So, for example, if I knew two sides and the angle in between them, I could figure out the third side. Or if I know all three sides, then I could figure out this angle. But that's not the situation that we have over here. We're trying to figure out this question mark. And we don't know three of the sides. We're trying to figure out an angle, but we don't know three of the sides. So the law of cosines doesn't seem, at least in an obvious way, that's going to help me. I could also try to find this angle, but once again, we don't know all three sides to be able to solve for the angle. So maybe law of sines could be useful. So the law of sines, so let's say that this is the measure of this angle is a, measure of this angle is lowercase b, measure of this angle is lowercase c, length of this side is capital C, length of this side is capital A, length of this side is capital B. Law of sines tells us that the ratio between the sine of each of these angles and the length of the opposite side is constant. So sine of lowercase a over capital A is the same as the sine of lowercase b over capital B, which is going to be the same as the sine of lowercase c over capital C. So let's see if we could leverage that somehow right over here. So we know this angle and the opposite side, so we could write that ratio. Sine of 40 degrees over 30. Let's see, can we say that that's going to be equal to the sine of this angle over that? Well, it would be, but we don't know either of these, so that doesn't seem like it's going to help us. But we do know this side, and so maybe we could use the law of cosines to figure out this angle, because if we know two angles of a triangle, then we could figure out a third angle. So let's do that. So let's say that this angle right over here is theta. We know this distance right over here is 40 meters. So we could say that the sine of theta over 40. This ratio is going to be the same as the sine of 40 over 30. And now we can just solve for theta. Multiplying both sides times 40, you're going to get, let's see, 40 divided by 30 is 4/3. 4/3 sine of 40 degrees is equal to sine of theta. And now to solve for theta, we just have to take the inverse sine of both sides. So inverse sine of 4/3 sine of 40 degrees, I'll put some parentheses here, is equal to theta. And that will give us this angle, and then we can use that information and this information to figure out the angle that we really care about. So let's get a calculator out and see if we can calculate it. So let me just verify I am in degree mode. Very important. All right, now I'm going to take the inverse sine of 4/3 times sine of 40 degrees. And that gets me, and I deserve a little bit of a drum roll now, 58. Well, let's just round. It's very close. If we round to the nearest, let's maintain our precision here. So 58.99 degrees roughly. So this is approximately equal to 58.99 degrees. So if that is 58.99 degrees, what is this one? Well, it's going to be 180 minus this angle's measure minus that angle's measure. So let's calculate that. So it's going to be 180 degrees minus this angle, so minus 40, minus the angle we just figured out. And actually, I could get all of our precision by just typing in second answer. So that just says our previous answer. So I get all that precision there. And so I get 81.01 degrees. So if I want to round to the nearest, let's say I round to the nearest hundredth of a degree, then I'd say 81.01 degrees. So this right over here is approximately 81.01 degrees. And we're done.